All right, you guys are getting too smart. Okay, I mean, I could not do it. I always do this every year, but I don't have to. Can you pull that back like a little bit? Maybe just like really fast do it? I don't know. 47, everybody understood exactly what to do? Because the book's picture is pretty weird, so I'm very skeptical of you guys. Anyway, all right, let's talk about number 47 at least. I have to draw the hyperbola. Basically what they wanted you to do is exactly what we did yesterday at the end of class with the ellipse, but do it with the hyperbola, right? Derive all the fundamental properties. So what is going on? Well, I have my foci, so here's the focus, and, well actually, I have a single focus and a single directrix, let's say. And using that single focus and that single directrix, can I toss me the blue marker and the red also? Whoa.
That was a good throw.
I wasn't seeing it coming. And the red? So we have the hyperbola, which looks like this, and then there's like the other branch of the hyperbola, which looks like this. Okay, so using this single focus and this single directrix, this hyperbola is generated. And we will call this point A0, we will call this point C0, and then D is again the directrix distance, the distance from the center of the ellipse to the directrix. And I need to derive all the relationships between A, B, C, D, and E. Okay, well, and then this is going to be negative A0. How do I do this? Amy, what do we do?
Well, A is the definition of eccentricity.
Yes, so we take the point A comma 0. That is on the hyperbola. By the definition of conic, since that point A comma 0 is on the hyperbola, then its distance to the focus, which is C minus A, over its distance to the directrix, which is A minus D, has to be the eccentricity. Everyone with me? Equals eccentricity, but then you also had to use the other point of the, it was a sneaky textbook problem because you had to use the other vertex of the hyperbola even though it was not pictured in the diagram. So the diagram was kind of actually like intentionally unhelpful. The only way to complete this is to know that the point negative A0 is also on the hyperbola. So it must also satisfy the definition of hyperbola, which is the distance to the focus over the distance to the directrix is the eccentricity. And this is A plus C, and this is A plus D, right? So then you get these equations, A plus C over A plus D equals the eccentricity. And from this point, you just do something very, very similar to what we did yesterday. It shouldn't surprise you that this is similar because in fact, the whole advantage of this new definition of the conics is that it simultaneously defines all the conics, so they should have all the same relationships. If you add the two equations, you get 2C equals 2EA, so C equals EA, so the eccentricity for any hyperbola is C over A, which unifies the definition with the old way we were using the term eccentricity. If on the other hand you subtract the two equations, upside down subtract, then you get 2A equals 2ED. So again, it's true in a hyperbola that the eccentricity is A over D. And then, if you put these two together, you get C over A equals A over D. So A squared equals CD. So D is A squared over C. Everybody got all of this?
Yeah.
Okay, cool. And then there was something else they asked you to do.
Lattice rectum.
The lattice rectum. So yeah, if you want to derive the formula for the lattice rectum of a hyperbola, then you know that this point is C comma Y, and you try to figure out what Y is. Well, this point Y must also satisfy the definition. So it's Y away from the focus, and it's C minus D away from the directrix. And so you just do the same thing that we did yesterday, right? Y over C minus D has to be E, so Y is EC minus ED, so Y is, you replace eccentricity with C over A, so that's C squared over A minus, and ED is just A, so that's A squared over A, and then C squared minus A squared, we just define that to be B squared. And so we get that y squared equals b over a. Follow? Okay, good. We now know lots of things about hyperbolas, so we can do a problem like number 11. Number 11 basically asks you to do everything for some. Maybe we don't have to do. Are you guys okay with this? We don't have to do this? Okay, good. Then I'll just take this homework also. Let's put it in a pile right here next to meow. No, it's not here.
That jump. Actually, I think like half of the thing was cut off.
What should we do with these?
Could you put it on the entire board?
Wait, how do you zoom out on this?
It's already zoomed out all the way, probably all the way.
Improve the reflective properties
No.
of parabolas. Did you actually want to?
Alright, we didn't get to do any of the fun things I wanted to do today, so I guess might as well just finish off our lame day by just getting some work done. And we'll do some more cool stuff later, I suppose. So, yeah, but I can't do that in 3 minutes. I'm tired of letting you guys out late, so.
Oh, okay.
You don't need to like bring them anywhere because they have like their triggers.
Okay, Lawrence and Zambuda, we're just going to do some classwork now. It's this worksheet, so you should like take that out. No. You need to do like some of the problems. And Jamie. Tall white guy, whatever his name is, I can't remember right now. Alright, so this is basically self-explanatory, I think, at this level. You have some pairs of second degree equations, and we would like to find the points of intersection. These second degree equations are going to be conic sections in all but extremely rare cases. And so what you should do is first apply techniques to make a semi-accurate sketch of the conics that are involved. That's obligatory. And then the sketch will indicate to you like how many solutions you should expect. And then you do the algebra, and then you confirm that those are the solutions. Follow? You have to draw a picture because sometimes you need your picture to exclude certain extraneous solutions to your system. Okay, I'm turning off this camera.